Hello friends, welcome to this video on normal distribution part 4. We will try to do some more problems in normal distribution in this session. The problem goes like this. In a test of 2000 electric bulbs, it is found that the average life is going to be 2040 hours with a standard deviation of 60 hours. We have been asked to estimate the number of bulbs that are likely to burn for more than 2150 hours, less than 1950 hours, between 1920 and 2160 hours. So this is going to be a data where you have 2000 bulbs. You have been given average and standard deviation. We will be estimating the probability for one bulb to have this probability, and then if we want it for 2000 bulb, then we will have to multiply the arrived probability with that of 2000. So that's going to be the idea over here. So the average lifetime is going to be normally distributed. We assume that it is going to be normally distributed. So given the datas n equal to 2000, so this is going to be equal to, so capital N has been given as 2000. The next one, average life. What is average? Average means mean. How to denote the mean by average or mean is given by the script called as mu, and we know that mu is given as 2040 hours. The next one is standard deviation. What is standard deviation denoted by? Standard deviation is denoted by the symbol sigma. Sigma is given as 60. So for this given data, we will try to estimate the value. Like the number of bulbs to be, we have to find the number of bulbs likely to burn. Let x be the number of hours that the lights burn for. So let x be the number of hours as the bulb burn for. So in which case the first subdivision asks you find the probability of the bulb is going to glow for, probability the bulb is going to glow for more than 2150 hours. So probability that more than means greater, x is greater than 2150 hours. Now we know that the given problem in x has to be converted into that of z using the standard normal variate transformation x minus mu divided by sigma. So the formula to recollect is z is equal to x minus mu divided by sigma. So the problem in x has to be converted to problem of z. How to do? Substitute this value. So z will be equal to 2150x minus mu is going to be 2040 divided by sigma. What is sigma? Sigma is 60. So 2150 minus 2040 divided by 60 makes it as, so when this is converted, you get it to be 1.833333, but you want only to two places of decimal, so restrict it to 1.33 alone. So we have the probability of z less, sorry, this is not going to be less than, it has to be greater than, sorry about it. So whenever it is going to be greater than here also it will be greater than. So we want the probability of z greater than 1.83. So let us shade this region. How will this region now look like? This is going to be our straight line. This is going to be our curve, bell-shaped curve we need to draw. So the bell-shaped curve is going to be symmetric about the line, which is going to be the line. The center line is usually called by the name x is equal to mu. Now when we transform it, the transformed line will now be referred by the name z equal to 0. So this will be the point z equal to 0. So this varies from minus infinity to plus infinity. I want 1.83, which is positive. Where will be the positive values? Positive values will lie over here. Positive values will lie over here. So drawing a line which is going to be in the right hand portion, we will have this line. Say suppose this is going to be our 1.83. So let us fix it. Okay, so now this is going to be our 1.83. Is it equal to 1.83? We want the portion greater than. Where is going to be greater than? The region which is going to be greater than will be here. So this is the portion which is greater than 1.83. So where we want is a portion beyond your center line. Keep in mind the data which is available in this table can be read only from the center line. From the center line only the table will give you answer. So when you want a portion beyond a greater than sign, we will have to keep that code word in mind. The code word is GST. So whenever you are having more amount that goes over there as tax, so greater the amount that has to be subtracted, greater the amount, then you will have to subtract. Subtract from what? So we know that half area from 0 to infinity is going to be equal to 0.5. So from this half area which is going to be 0.5, let me subtract the table value where it is available for. Where is the table value which is available for? Table value will be available for 0 to 1.83. So when I am going to subtract the 0 to 1.83 from my half area value, then I will be getting this required area value. So this is going to be probability of z greater than 1.83. So it is going to be GST from 0.5 subtract 0 less than z less than 1.83. Now where is going to be my 1.83 in the table? 1.8, you look vertical, and 3 over here in the horizontal way. So the table value is going to be 0.4664. When you subtract it, this gives you 0.0336. Now this is going to be the probability that one bulb will glow for more than 2150 hours. But how many such bulbs we have? We have 2000 such bulbs. Therefore, the number of bulbs that glow for more than 2150 hours will be equal to, what is the formula? We need to recollect, n into probability of x. So what is the probability of x? It is 0.0336. What is n? N is going to be 2000. So when I multiply, what is the answer? The answer which I get will be 67.2. Now 0.2 bulb I cannot have, so round it off. So this will give me the value as 67. So out of 2000, how many bulbs glow for more than 2150 hours? 67 bulbs glow for more than 2150 hours. Now we will move on to the second subdivision. What is the second subdivision asking us? Less than 1950 hours. Less than 1950 hours. So this problem, which is going to be less than in x, has to be converted to less than in z. Z is equal to x minus mu divided by sigma. So what is the x which we need to convert? 1950 minus what was the average lifetime given as? So it was 2040, and what was sigma given as? 60. When we subtract, the answer will be equal to minus 1.5. So the value of x will now turn as z, which is going to be less than minus 1.5. Now let us plot this data. When we are going to plot it, what happens? This is going to be our bell-shaped curve, and this is going to be my center lines called as z equal to 0. And now varying from minus infinity to plus infinity, where does minus 1.5 lie? It lies towards your left hand side, minus 1.5. So what is the region required? This is going to be the region required, less than 1.5. But do you find any negative values in your table? No, right? So for negative values, what we need to do? We need to go for mirror images. So what is going to be the mirror image of the above image? So one more time, draw your bell-shaped curve. So how much ever you have plotted over here in the left hand side, go and plot the same for your right hand side. This is becoming minus 1.5 to positive 1.5. So the value will be from 1.5 to infinity. So this portion which we have over here will be the same as this portion which we have over here. So these two datas are one and the same over here. So minus 1.5 can be taken as positive 1.5 by symmetry. So what happens now? We will do this value calculation. Now we have this z probability of Z greater than 1 minus 1.5 to be greater than positive 1.5. Look into the symbol greater. Greater means GST. GST means they will take away your money. So what you will have to do? You will have to go for subtraction. Greater means subtract. From where you will subtract? The table can read only from a beyond portion. So what you will have to do? From your 0.5, subtract this value which is available from 0 to 1.5. So from your 0.5, what you will have to do? You will have to subtract this quantity, which is the quantity from the table. I can get it from 0 to 1.5. So subtract this. So what will be the answer? This will be from 0.5 I subtract 0 less than Z less than 1.5. Go and check with the table value. Where is going to be 1.5? 1.5 is here and 0 is here. So what is the table value corresponding to it? It is going to be equal to 0.4332. So when we subtract, the answer is 0.0668. So this probability is for one bulb to glow for less than 1950 hours. So how many such bulbs we have? Therefore, for 2000 bulbs, the number of bulbs to glow for less than 1950 hours will be equal to capital N into probability of X. So 2000 into your 0.0668. So this will give you 133.6. So this can be rounded off to 134 bulbs. Now moving on to the third subdivision. So let us move to the third subdivision. So what will happen over here? In the third subdivision, we want the probability of 1920 less than X less than 2160. So convert this also. Z equal to X minus mu divided by sigma. So this is going to be equal to 1920 minus 2040 divided by sigma is 60. Convert this also. So 2160 minus 2040 divided by 60. So this will give me the value as minus 2. This will give me the value as plus 2. So the value which was in X has now converted into a value in Z. So where is the region I have? The region which I have is going to be from minus 2 to plus 2. So this is going to be the line Z equal to 0. This is going to be minus 2 and this is going to be plus 2. So I want the region between minus 2 to plus 2. So this is my required area which I need to compute. But I know that I don't have a negative value for my table. So this negative value which is over here has to be shifted to the positive side by taking the mirror image. So when I flip this and paste it to the opposite side, what will happen? It will actually be a replica of the one which is available over here. So this is nothing but 2 times of the quantity from 0 less than Z less than 2, because when I fold it, it is the same equal area over here and this portion are both the same. So it becomes 2-fold of the area. So just go for 0 to 2 and then multiply it with 2. So from the table 2.00. Where is our 2.00? 2.00. So it is 0.4772. 0.4772. When we multiply, the answer will be 0.9544. So the probability of 1920 to 2160 hours less than that will be 0. Therefore, for 2000 bulbs, the number of bulbs that glow between 1920 and 2160 hours will be equal to capital N into probability of X. So this will be 2000 multiplied by 0.9544. When we multiply, we have it as 1908.8. I can't have 0.8 bulbs, so round it off to the nearest integer. So that becomes 1909 bulbs to glow between 1920 and 2160 hours. So when you have been given with a capital N, so make sure that the probability which you get at last has to be multiplied with the capital N. So that will complete the problem entirely for the number of bulbs. Thank you.